But today, what I'm going to tell you is you could also just memorize these. Okay? So you can memorize the derivative of arc sine x, which is 1 all over square root of 1 minus x squared. Okay? That's one of them you can memorize. The other one that we talked about yesterday was the derivative of arc tangent, which is equal to 1 over 1 plus x squared. Okay, and lastly, we did the derivative of arcsecant, arcsecant x, which is equal to 1 all over.
Like, that's just the rule, even if it's like a different number?
So, yes and no, okay?
You just plug in a different number?
So what it is, it's the, if this was like 3x, for instance, right? Eventually you would take the derivative of that 3 and it would end up in your numerator, okay? I'm telling you, you can always go back to the triangles. The triangles will always help you get the right derivative. If it's just an x though, oops, I even forgot the x here. If it is just x though, it's nice to kind of memorize these.
Is it usually?
Usually, typically, yes. Brendan.
With arcsecant, does that x have an absolute value on sides of it?
It does. Okay.
And is it because of the square?
No, it's because of inside secant, you can't have negative values in certain quadrants. Okay. All right. So, ladies and gentlemen, the two things that we have to talk about are what we've been going back to after we learn a new derivative. What's something that we can calculate or find once we know how to take a derivative? We know how to find a tangent line, okay? So that's one example I want to go through with you, is just how to find a tangent line. Stop! I can make you do it all on your own. Oh my goodness, I haven't heard this much complaining since I asked my daughter to brush her teeth last night. Okay? Find the equation of the tangent line. Okay? So, y equals 1/2 arc cosine x. Now, the point that works is negative radical 2 all over 2, and that's at 3 pi all over 8. Okay? And if you're wondering why is it over 8, it's because I have this 1/2 out front. It would be 3 pi over 4, but you're taking half of 3 pi over 4, which happens to be 3 pi over 8. Does that kind of clarify some things?
Move it to the side so I can see the formulas up there.
Okay. All right. So, ladies and gentlemen, leave that 1/2 just as a coefficient, and if we go back up, oh, I didn't give you arc cosine, did I?
No.
Negative arcsine.
It is. So the reason it's negative is because if we take a derivative of cosine, what does that give us? Negative sine. So we treat it like arc sine, and it's just the negative of it.
So do we have a rule for arc sine too?
Well, we do. The arc sine one is up here, but arc cosine, like I said, if we think about it, yeah, so arc cosine would just be this, but negative, because when you take a derivative of cosine, it's negative sign. Yes?
What about cosecant and cotangent?
Cosecant and cotangent we really don't use, and like I said, if you ever have that situation, go back to your triangle, but usually there's some undefined stuff that's happening because of the way it is. Okay? But typically, like I said, guys, for these, I'm totally anticipating you guys to have to go back and make a triangle, which is fine. The triangles will always work. Okay? So that means y prime is going to be equal to 1/2 times negative, because I'm taking a derivative of cosine, 1 all over radical 1 minus x squared. Okay? Now, if we have this, and I want you guys to find the tangent line, what's the first thing we do? Yep. We find the slope. So what are we going to plug in? Yep, the x value, which is? Yep, radical 2 over 2, or negative of that, yes. So 1 minus negative rad 2 all over 2 being squared. So we just got to do some math there. So 1/2 times negative 1 all over, what's negative radical 2 over 2? Ooh. Come on, guys. Yeah, so what's negative radical 2 over 2 being squared? It's not negative. It will be positive, but I will be subtracting, so the square root of 1 minus 1/2, okay? Now if we go through and we simplify that a little bit more, m is equal to 1/2 times negative 1 all over square root of 1 over 2. If I look at this, what's the square root of 1? 1 all over square root of 2, but I have a fraction on top of a fraction, right? So this is really equal to 1/2 times negative rad 2. And therefore your slope is negative radical 2 over 2, which is kind of our x value that we even started with. Well, this 1 minus 1/2 is 1/2, right? If I take the square root of 1, I get 1. If I take the square root of 2, that's still square root of 2. So I have 1 over square root of 2. But you can't have a fraction on top of a fraction. I mean, you can, it just looks ugly. This whole thing right here just simplifies to negative rad 2. Okay? So that's our m. What do we do from here? Yeah. We're just going to plug in all our values. So my slope is negative radical 2 over 2 times x minus negative rad 2 over 2. That's kind of interesting how that's going to simplify. If you want to, you could go through and simplify this, or you can just leave it as such. Okay? So that's the tangent line. It looks ugly. This would just be a test of your algebra skills, is what it would be. Yes?
Wouldn't it be x plus radical 2?
It would be. Yes, good catch. Because you are subtracting the negative. Okay. All right. The other item I ask about when we know how to take a derivative.
Oh yeah.
Maximums and minimums. What do we call those? Extrema. Okay? Relative extrema. So that's our next part. So, oh, I didn't even make this bigger. Sorry, guys. So, find any relative extrema. Okay? So here's the function. So h of x equals arcsine x minus 2 arctan x. Okay. H prime of x. Now, you could go through and do the triangles. We could just look at our cheat sheet up top, which for your homework I'm totally okay with. I have no problem with you guys going back up top and just looking at what it is. Okay? So, what's the derivative of arcsine?
1 over radical 1 minus x squared.
Okay. And then if we take a derivative of arctangent, again, that 2 is just a what? Coefficient.
Minus 2 over 1 plus x squared?
Yep. Okay. So far, so good? Mm-hmm. Okay. How do we find extrema? We would let this, what? We would let the whole equation equal 0. Now, guys, you're going to have to use a calculator for this. Okay. So, Actually, I didn't use a calculator for this. I kind of did, but you could plug this in your calculator and look for what? X-intercepts. How I made this a little bit simpler is I moved this over to the other side if you're kind of curious on how this math is working. Some of you guys are like, nope, don't care. But, so you could do this.
Enlightening.
Right? Yeah, I know. So interesting. So basically what I did is I added that other fraction to the other side, right? I'm now dealing with positives, which is what I like. I don't like dealing with fractions, so what do you think I'm going to do? Oh, I hate that word, but yes, I'm going to multiply each side by the denominator. Okay? I hate cross multiply because my freshmen don't know how to use it correctly.
Yeah, teach them.
No, I don't. I have to teach them the correct lingo. Cross multiply is not a mathematical term.
Why do you know their math skills if you're an English teacher?
Huh?
Why do you know their math skills if you're teaching English?
She's a math teacher.
Never mind.
Okay. Guys, you look up cross multiply in math, it doesn't exist. It's a made up word. Kind of like the Seaman triangle. I get behind that, but cross multiply is made up.
What
Now,
is it called?
it's multiplying by your denominators to cancel out or get a common denominator.
I feel like
No.
I feel like cross multiplication is the best way.
It's like-
it's easier to say than just multiplying by the
Multiply the
denominator.
denominator.
I'm just saying, like, so here's the reason why I hate it is because kids get like two fractions that are being multiplied. Not an equal, not an equivalence relation,
really?
and they will cross multiply when they're multiplying fractions, or they're cross multiplying when they're subtracting fractions. That's why I hate it. They don't understand how to use it. So when I say multiply each side by a denominator, they understand that. Yes?
I get you.
Okay.
We get you. We're just
I know you get me, but okay.
Cross multiplication.
So ladies and gentlemen, what would I do to help myself out here?
Square both sides.
I would square both sides. So if I take this side and square it, and I take this side and square it, there is one algebra mistake that will happen here, and you guys will forget to square the 2. So it'll be 4 times 1 minus x squared equals, and then over here you will get x to the 4th minus 2, or I'm sorry, plus 2x squared plus 1.
Oh yeah.
I just did 1 plus 6.
Yeah. me
Okay. So, and then you can move everything to one side. You could distribute that 4. So I would get like 4 minus 4x squared equals x to the 4th plus 2x squared plus 1, blah, blah, blah. So 0 equals, again, x to the 4th plus 6x squared now minus 3. And again, this you could plug in and find your x-intercepts. And this function makes way more sense to you guys than that. They'll both give you the exact same thing though. Okay? I understand why you guys plug this in because you're understanding, okay, it's a quartic function. Like, it could have 3 max and mins, it can go up and down and blah, blah, blah. It's an even function. As we're this, you look at it, you're like, I have no idea what that looks like. Okay? So if we plug this into our calculator, we would see that x equals 0.681. This would be going from a negative to a positive as it crosses the x-axis. So if it's going from a negative to a positive, what is that producing? It's producing a minimum. So this case, it's a relative min if you graphed it. And then the other one that you're going to get is going to be negative 0.681. Again, has that even property. This one's now going from a positive to a negative. So it is it's a relative max. And again, plug that in the calculator, see what I'm talking about if you don't understand. And if you need me to come over and explain it, I can do that too. Okay?
Is that it?
That's it. These are the 2 things I needed to talk about. The other notes I'm not talking about until Monday. So you guys have...
Sorry.
So you guys have the rest of today and tomorrow to work on this homework. I know it's hard and challenging, but...